All right, this is the 2-2 warm-up. So it starts with your patterns, right? Number 1 says describe a pattern in the numbers, and then write the next number in the pattern. 20, 22, 25, 29, 34. What's happening? What's the pattern, Nico? What's the pattern?
X plus 2, then plus 3, plus 4.
So you're adding 2, then you're adding 3, and you're adding 4, right? 2, then 3, then 4, then 5. Then you would add 6. So the next number would be 40. Number, oh, you have the answer to the next one. Found a counterexample for the following conjecture. If the sum of two numbers is positive, then the two numbers must be positive. What's a counterexample?
I put 10 plus negative 5 equals 5.
Okay. That's a counterexample.
Put 10 plus negative 2 equals 8.
That's a they're both counterexamples. Yep.
I put 6 equals negative 10 plus 4.
Except that that's not right. Right? What is negative 10 plus 4? Negative 10 plus 4 would be?
Negative 6.
Oh.
Negative 6.
Oh, wait.
Isabel.
4 plus 10. Oh.
That's fine. Okay. Any of those work, except for Marcy's. Any of those work, right? The sum of two numbers. You want the sum of the two numbers to be positive, but you want both numbers not to be positive. That was what you were looking for there.
So 10 plus negative 4 would be 2.
That would work. Yep. All right, so 3 says the scatter plot shows the average number of hours of homework done per week by a student during the first 10 weeks of the school term. Make a conjecture that could be true and explain your reasoning, Jonathan.
If the week keeps going, then you will receive more homework.
Okay. So as the weeks keep going, you receive, that's not how you spell receive, more homework. Okay, what's the reasoning?
Because it keeps going based on how many weeks you work.
Okay, the pattern increases, right? Increases. Well, the pattern of homework increases as weeks go on.
So I disagree with that because, like, let's say you're at week number 100. I don't think you're gonna have 100 hours of homework.
So the biggest thing here is could be true, right? We're not saying that this is definitely stuck in stone or set in stone, and it's a conjecture, which is something you get to inductively based on a pattern. So it's not fact. So those are two different things. Okay, so we're basing this upon a pattern, not that it is set in stone that would be a fact. Yeah.
Would the hours of homework you do increase as the weeks go on?
Yep.
So what is a conjecture?
You tell me. It's a vocab term you
so
learned
that
yesterday.
would work as an answer?
Yeah.
No, like, it's just a...
What wouldn't work is the hours of work decline as the weeks go on. That would be false, right? Because this is increasing. But anything along that line, the longer you go in the year, the more work you get, and the number of hours of homework you get, anything along that pattern would have been fine. All right, 4, use the law of detachment to make a valid conclusion in the true situation. If two angles are complementary, then the sum of their measures 90 degrees. C and D are complementary. Mars?
I put...
Well, wait, Mars was going to answer it. All right, so if C and D are complementary, then what?
Angle C plus angle D equals 90 degrees.
Good. So it's really the measure of angle C plus the measure of angle D equals 90 degrees. Okay, good. 5, use the law of syllogism to make a valid conclusion in the true statement. If water is at room temperature, then it's liquid. If water is liquid, then it's frozen. Then it's not frozen, sorry. Go ahead.
If water is at room temperature, then it is not frozen.
Good. If water is at room temperature, then it is not frozen. Okay, you bridged the two together. All right, for the next ones it says, use the true statements below to determine whether the conclusion is true or false. Explain your reasoning. If Janine does her homework, then she goes to the movies. If Joaquin goes to the movies, then he buys popcorn. If Janine goes to the movies, then she buys popcorn. Janine does her homework. 6, Janine buys popcorn. True or false, Jonathan? True. And how do you know that?
Because if she does her homework and then she goes to the movies, and when she goes to the movies, she buys popcorn.
Good. So what's that law called?
Syllogism.
Good.
What is that law?
If, then, and then the then repeats. So if she does her homework, then she goes to the movies. If she goes to the movie, then she gets popcorn, so you take out the repeated part.
On the quiz Fridays, do we have to like explain what law it is?
Yep.
This spelling right?
I actually think it's multiple choice, like you circle it or not, so. Yeah. All right, 7. If Janine goes to the movies, Joaquin goes to the movies. True or false?
That is a false statement.
Okay, and why?
Because you don't know if Joaquin's gonna go when Janine goes.
Good. There's absolutely no relationship between this statement and anything about Janine. All right, 2-3 is called using postulates and diagrams. So there's a bunch of postulates in this section in which some of them are just straight up common sense, but we're going to have to learn their names and then how to use them. And then we're going to get a couple of diagrams so you're going to learn some notation on the diagrams. We start with these 4, okay? So the number of the postulate doesn't matter. That just means it's the first postulate mentioned in the second chapter. So that's what, when it says 2.1, that's all that means, okay? But the name is important. So the first one says 2 points postulate. And what it says is through any 2 points, there's exactly 1 line. The second one is line point postulate. And it says a line contains at least 2 points. Mars.
So it's basically like reverse psychology type of thing. Like 2-point postulate is like 1 line, but then line postulate is 2 points.
Facts.
Sure. They both have 2 points though.
In a line.
The 2-point postulate starts with the words 2 points. Through any 2 points, there's exactly 1 line, whereas the line point starts with the line. The line contains at least 2 points. Okay, so basically this would be like an if-then statement would be there are 2 points, and if there are 2 points, then there's exactly 1 line, right? That's the 2-point postulate. The line point says a line contains 2 points. So you have the line, and then you know it has at least 2 points. So it could have more than 2 points. So it's kind of like the converse to each other. The first one says through the 2 points there's 1 line, and the second one says that the line contains at least 2 points. The third one says a line intersection postulate. So think about a line intersections. 2 lines would intersect at exactly 1 point. Okay, that's what this one says. If I cross 2 lines, they meet at exactly 1 point, 1 and only 1 point. The 3-point postulate says through any 3 non-collinear points, there's exactly 1 plane. So if I have 3 non-collinear points, there exists exactly 1 plane. So if you are a flashcard person, okay, I will post the Quizlet that's going to cover this stuff. It'll cover all the stuff up to this point, like what's a converse, what's an inverse, and all that stuff, and then it will also include these postulates.
Is the quiz hard?
The quiz is not hard by any means unless you have no idea what this stuff is.
But
Like if
have,
you
like, a
know what the
slight idea-
vocab, if you know what an inverse is, a converse is, a contrapositive, a biconditional statement, a negation, that all came from one section. And then all of these, then the quiz should not be hard.
Okay. How many questions?
10, Friday. All right, here's 3 more. The plane point postulate says a plane contains at least 3 non-collinear points. So it is the reverse of the last one, or the converse of the last one. The last one started with the 3 non-collinear points, so then there's exactly 1 plane. And now we say a plane would have at least 3 non-collinear points.
Aren't they the same?
You'll see these in a diagram where the if is the plane that's like empty. So it almost looks like this. Like here's the plane. So then the plane would contain 3 points. That's this one. Whereas the last one, you'd have 3 points.
And you put the plane in it.
And then the plane comes around the 3 points.
Oh.
So does that make sense? Yeah. So that's your if and your then. If you have 3 points, then the plane. If you have the plane, then you have the 3 points. Non-collinear points. All right, 2-6 says the plane line postulate if 2 points are in a plane, then the line that contains them is in the plane. So this would be like a plane with 2 points that leads to a plane with 2 points and a line that contains those 2 points. The plane intersection postulate says if 2 planes intersect, their intersection is a line. So if they intersect, then their intersection is a line. So it's almost like a tent in that one. Like if they meet at the top, it's going to be a line. If they crisscross through the middle, their intersection would be a line. All right, now you get your diagrams. So this is dealing with perpendicular, okay? A line is perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects that point.
How do we know that?
Where the line hits the plane is a right angle, okay? So again, picture even the top of your desk or a piece of paper and you tap it with a pencil. If you're holding it straight up and down so that it forms a right angle, which is what these little marks are, okay, those are right angles, then not only is it perpendicular to the plane, but it is also perpendicular to every line in that plane. So I can draw an endless amount of lines through this, and where they meet that point or where they meet that line at that point would all be perpendicular.
Is that just saying that every line that intersects a plane is in a mixed 90-degree angle?
No, because you could slide a line in sideways. It's not going to be 90 degrees. It's just saying that if there is one that's perpendicular, then every line on that plane that intersects that line is also perpendicular. Yeah. All right, so this one is in visuals. State the postulate illustrated by the diagram. Sophia.
Line intersection postulate.
Okay, which would say?
I don't know.
What's that say? Yeah.
If 2 lines intersect, there will only be 1 point.
Then they intersect at 1 point. Exactly 1 point, right? Yep. How about B? Yeah.
The plane intersection postulate.
Which says?
It says that will always be a line that intersects.
Where 2 planes intersect? Yep. There's exactly where if 2 planes intersect, then they intersect at exactly 1 line. All right, this one says use the diagram to write examples of the plane point postulate and the plane line postulate. So what's the plane point postulate say? Yeah. Hang on. Go ahead, Jonathan.
Wasn't it the one if there's 3 points on, or there's 3 points that are...
Okay, so the plane point says a plane contains at least 3 non-collinear points. So if you're trying to use this specific diagram and you want to use it to show this, okay, it means give names. So give me 3 non-collinear points that are contained in one of those planes. Sophia.
BAC.
Would be contained in what?
P.
So in plane P. Yep. Plane P
Yeah, but they're the same line. though.
contains B, A, and C are not. They're 3 non-collinear points. Good. Okay, then it says, how about the plane line postulate, which says if 2 points are in a plane, then the line that contains them is in that plane. Santi.
Q and C intersect and the line is M.
Q's the name of the plane.
B, A, C. And
We're trying to find 2 points that are on the plane, and then the line that contains them would be in that plane. So give me 2 points that are on a line.
B and A.
B and A. So B and A are on what plane?
P.
Plane P. And line, what line contains A and B?
N.
It could be line N or line N. Or it could be line A, B lies on plane P.
Yo, why wouldn't it be line M? Because Q and P are intersecting.
But you need 2 points on this line. That's not this, you're talking about a different postulate. You're saying that the two planes intersect at one line. That's the plane intersection. This is saying the plane line postulate. The plane line postulate is this one.
Okay.
Does that make sense? You're just referencing the other one. It's not that that postulate's wrong, it's just not that same one. All right, this one says, which of the following statements cannot be assumed from the diagram? There's a lot going on there, right? So you've got like the red plane that's running almost like forwards and backwards. The blue one is running vertically. You've got a right angle drawn where line AB intersects line BC, okay? So, and the first one says, let's say, we'll label this A. A, B, F are collinear. Is that true? Yes. B, sorry.
I know the answer.
Good, hang on. E, B, and D are collinear. Are E, B, and D collinear? Could they be? Maybe.
They could be, but they're.
So that's a maybe, right? Yeah,
Okay, go back.
sure. Line AB is perpendicular to line S. Is line AB perpendicular to plane S? Yes, because it is perpendicular. Okay. D says C is yes. So this is a yes, this is a yes. Line CD is perpendicular to plane T. Can you determine that?
Wrong.
No. How come?
Because there's no mark of congruence.
There's not congruency.
Perpendicular.
You need the right angle mark, okay? AF intersects BC at point B. AF is this one. BC is this one. It intersects at point B, okay? So the real question is, can you draw a line through this maybe? Can I draw a line through E, B, and D? If you physically take, especially in notability, and you draw yourself a straight line, can you cross it through those three? And you can. The only one, oh, let me group it. The only one that's a no.
CD is perpendicular to plane T.
Correct. So this one was also right. So D is the only one that is that cannot be assumed from the diagram. Yeah.
Was something like E, B, and T, like where like it doesn't have a line through them? Will that be on the test that we have to kind of like?
Well, we haven't made your test yet, but I would probably say no. There's going to be a diagram, but it will be pretty straightforward. Yeah.
Yay.
Okay, last one. Name a pair of supplementary angles and a pair of vertical angles in the diagram. So this is a review of skills we learned from before, okay? How do I know if they're supplementary from a diagram? What are they called?
Live.
What are they called? If you can see them in the diagram, that they would be supplementary.
Straight angle.
A linear pair, good. Okay, so give me an example of a linear pair.
Ray WT. Or no, wait, it's angles, right?
Angle, yep.
TWP.
TWP, which would be this one, would be a linear pair with what?
PWV.
PWV, this one, that works. What else?
Or like
TWQ could be with QWV, that works. What else?
Oh, there's more?
Yeah. So we just did this one with this one, right? You can move completely around this circle, right? I could do QWV and VWP, any two that are adjacent to each other that form that line. No, like for real. All right, and then we did what? QWV and angle. Oh, wait, I did that one already. These are these two. What didn't we do? WT, and TWP. Okay? So there are 4 pairs if they're like that. How about vertical angles? Jonathan. VWQ, is that what you said? And TWP, good. So these 2 are vertical angles, like 1 and 2. We can put numbers here. 1 and 2 are vertical angles, and then 3 and 4 would be vertical angles, which would be angle. Good. Okay, these are vertical angles. And these are supplementary because they are a linear pair.
So you're gonna ask for all this on the quiz?
So a linear pair and vertical angles will be used almost the entire year.
So we'll have to,
Yep. And then again, we're going to make sure we submit to Canvas. You're going to make sure I see your username and your score, okay? And you're submitting it. There's still not work to be done, but once there is, you'll know to make sure that you attach it.